Greetings, chemistry students. Today I'm going to show you how to do some problems on this kinetics worksheet number 1, which is also linked in Google Classroom, and I'm going to have you do some problems on it. This one is going to involve a little bit of some skills that we haven't quite used yet. So I'm going to show you a few examples. So for instance, in question number 1 here, this says, what is the order of this reaction with respect to A, B, C, and D? So we're going to be writing a rate law. So our rate law expression in step 2 is going to be rate equals K times then the concentrations of each of the reactants raised to the power of their order. So the first thing to do is we need to find trials where one thing changes and everything else stays the same. So for instance, between trials 1 and 2, B doubles while everything else stays the same, and the rate also doubles. So if you double B and you double the rate, that means that whatever you did to the concentration, you did to the rate. That is first order. If you prefer to use the formulas, we could do 8.4 times 10 to the negative third divided by 4.2 times 10 to the negative third equals 0.2 over 0.1 to the n. 2 equals 2 to the n equals 1. So you can do the math, or you can just kind of do it this way. Now, if you're going to do it this other way using the words, you're going to want to write that down if you're actually doing a free response. You got to show how you arrived at your answers. So you would say from trials 1 and 2, when B was doubled, the rate was doubled, so it's first order. So now let's compare. In trials 2 and 3, A is doubled, the rate stays the same. So if we manipulated the concentration of A and the rate was unchanged, that means that the rate is unaffected by A, so it is 0 order with respect to A. So now we can just kind of ignore A's all throughout. A does not affect anything. So now we can find another one to compare. That would be trials 3 and 4, where B stays the same, C stays the same, D is tripled, and we can see what happens with the rate. So 7.56 times 10 to the negative 2 over 8.4 times 10 to the negative third equals 0.3 over 0.1 to the n. So 7.56 times 10 to the negative 2 divided by 8.4 times 10 to the negative 3 is 9. So n must be 2 because 3 squared is 9. Now we're left with the tricky one because we can't use trials 6, 7, and 8 because they're missing information. So the only way we're going to be able to tell about the order with respect to C is by using one of these other trials, but there's nothing where everything else stays the same. So what we're going to have to do, this is where we're going to get to something new here. So let's compare trials 4 and 5, where we have 6.05 times 10 to the negative 1 over 7.56 times 10 to the negative 2 equals, and then for C, we've got 0.2 over 0.1 to the n, but we also are going to include 0.6 over 0.3 squared because D is also changing. Because essentially what this formula is doing when we're doing these calculations for order, we're essentially taking the entire rate law equation and dividing it by itself, except that the k's cancel and anything else that's the same cancels. So all we have left in our equation are rates and the thing we don't know. But we can use trials where multiple things change as long as we know the order of everything else. So if we do a little bit of math here, 6.05 times 10 to the negative 1 divided by 7.56 times 10 to the negative 2 is 8 equals That's going to be 2 to the n times 2 squared. And 2 squared is 4. So 2 to the n equals 2. So n equals 1. It's first order with respect to c. So our rate law would say rate equals k times the concentration of B times the concentration of C times the concentration of D squared. And we don't include A because it's zero order, and you don't have to write the ones for B and C because we typically don't do that. Then if it asks what's the overall order of the reaction, we just add the B plus the C plus the D orders together. 1 plus 1 plus 2 is 4. All right. Then for number 4, it asks if the concentration of D in trial 4 was quadrupled while everything else stayed the same, what would be the value of the new initial rate? Well, if D gets multiplied by 4, the rate gets multiplied by 4 squared, or by 16. So you just take 16 times the 7.56 times 10 to the negative second, and you get that the rate would be 1.21. Right? And then it's asking what's the value of the specific rate constant. Well, that's going to be a case of picking a trial and plugging the numbers in. Right? So I'm going to leave most of the rest of this worksheet up